They're different sizes, different capabilities, what have their names that throw up right, left, and center. And you're sort of always thinking about how do you make sense of them? When do I use which one of these? And and that's where I think after you sort of going through 4 or 5 of these projects, something struck me that we could start thinking about these along 2 axes and a mapping to human capabilities. So let's go over there. I'll show these right now. So now what you have is that on the x-axis, you have this ability to think about experience and intelligence of a human that I want you to map to the size, parameter size of the model. And then on a y-axis is the training data that is given to a particular model, and you map it to a specialization that a human goes into. So taking this analogy, you would think about starting to talk about early interns as juniors or very small language models, right? Very, very minimal, just fresh out of graduate school, able to do somewhat, but not a lot of practical work. But then if you take them and you try to specialize them or train them in one particular area, then those models become specialized or fine-tuned, and they become like, maybe a second year front-end engineer or DevOps engineer or back-end engineer. And that's where you can see you can map those into, specialized, distilled or tuned GPTs like BioGPTs or FinGPTs. If you move then on the right-hand side of this axis, you start thinking about people which have greater experience with time and intelligence. And what happens with greater intelligence and experience is that not only are they able to respond to questions based on their and the data that has been fed into them or the things that they've experienced, they can actually connect the dots between things that were not present and still give reasoned answers or give suggestions over there. So seasoned professionals are corresponding to these large language models. So one thing that I want to admit at this point before I go into foundational models is that this two-dimensional axis is a false flag, basically. Why? Because in any real world scenario, when you're solving any problem, you're seldom looking at one area of specialization, right? Typically, you have n domains of specializations in any problem space, and in the world there the n dimension is even large. So essentially you could take a model and the model could be specialized in by providing it data sets for different domains, and it'll become specialized in each one of those domains. So this is axis, the y-axis is actually n-dimensional. Obviously, I can't show an n-dimensional space on a two-dimensional screen, so I've sort of simplified this over here. But when you talk about foundational models, which are running on web scale size data set, which you could empirically say covers all domains of human knowledge, then the architectural or the foundational models are basically covering your sort of top right corner of this maths in human. You think about Leonardo da Vinci, you think about Ibn Khaldun, you think about people like Einstein. Now, these people who have got covered a lot of areas, have a lot of and have a deep insight and deep experience and deep intelligence across many different domains. And so now, once you have this mapping, and so again, this is where GPT-4, Cloud 3, Opus, these are all foundational models that start showing up on that position of this map. Now, why this becomes useful? Like all frameworks, this is not perfect, right? But this does give you an idea of how you start selecting which model to use for what problem that you have. So just like if you were building a software and you had a bug, you wouldn't bring in your CTO to solve that bug, right? that would be a massive misuse of resource, right? And resource inefficient usage. Just like that, I think having this framework allows you to think about, okay, here is the complexity of the problem that I'm trying to address, and Henceforth, this is a selection I should use, which is the most cost and task efficient way to solve that problem. So this framework, I've seen myself that whenever you do this anthropomorphic mapping of your problem to the solution being a human, and then taking this framework and mapping it to different models, there's a very good chance that you're able to make a very intelligent choice of what sort of LLM to use. So that this is the core new framework that I wanted to share out.